Here we have a piecewise function, and fx looks different for different intervals of x. For example, if x value is x plus 1, if x plus 1 in the interval where x is less than 0, and this is now this, let's get it there, it's this one here, this is now the x plus 1, and it goes, but it's less than 0, so that's why it ends there at y is equal to 1. We'll look into that now further. Then the value of fx is minus 1. The y value is minus 1 because remember fx just means y. So y is equal to minus 1 where the x is between 0 and 2, and you can see that there's the x, there's 0, and between 0 and 2, let's do that, between 0 and 2 you can see the y value is negative 1. And the y value is 1 where the x is equal to 2, and that's that dot there. And then the y value is x minus 3 if x is greater than 2, and you can see is that line there. Okay, now let's see how this fx behaves at x equal to 0. Okay, let's consider this one first to understand limits. Okay, so at x equal to 0, we know the y value is negative 1. So if we put f is equal to the x is 0 into the fx, we know the y value is negative 1. You can also see it from this intervals there between x greater and equal to 0 or less than 2, the y value is negative 1. That's what you can see there. But looking at the limits, well, first we consider the limit of fx but as x approaches 0 from the negative side. And this is important because we can approach the limit from the right or the left hand side, from the positive or the negative side. So now if we approach x equal to 0 from the negative side, that means, and let me get another color here. Okay, so here you go, and the x increases and you turn to x0. You see there you go towards x0 because there's the x0, but now as the x approaches 0, the y value is increasing and it approaches 1. It approaches 1 and never reaches 1, but for limit's sake, when you do the limits, that's not necessary to look at that. So all you do is then you just look at the y value it's approaching, and for our situation and for this example, well, that value is just 1. That value is just 1. Okay, now if the fx approaches if the x approaches 0 from the positive side, okay, now here the x approaches from the right hand side, from a positive side it approaches x0, what will the corresponding y value or fx value be? Well, it will just be negative 1. But you see they differ, and that's why we can say this limit does not exist. So the limit as x approaches 0, because now when you say it approaches 0, we are thinking about it approaching 0 from the negative and the positive side. Well, we will say it does not exist. Okay, but let's look at another example. Let's look at where x is equal to 2. Okay, let's look at that, x equal to 2. Maybe I'll just get also another color. Okay, well, we know that if we say f and you put the x value 2 in there, we know the corresponding y value will be this one there, because where x is 2, the y value is 1. You can also determine it from these intervals or these restrictions, and you can see here that where the x is equal to 2, the y value is 1. Okay, now what happens to fx if we take the x and let it approach 2 from the negative side? Now from the negative side, okay. So now the limit from the negative side, as x approaches 2, it never reaches 2, and that's important. So there's the x2 is there, and it approaches to 2 there. Then the corresponding y value will be -1. Okay, and so the limit of x tends to 2 from the positive side. What will that be? So if you go from this right hand side, the positive side, and you approach the x towards 2, then the corresponding y value is also -1. And because the right hand and the left hand limits are exactly the same, we can say the limit of x approaching 2 of fx is equal to, well, -1. Remember, we are working with limits here. It's approaching that 2. It's not necessarily reaching that 2. But we know if we substitute 2 into the fx, we actually get 1. But here the limit does exist, and it is the same.